Hey guys, here is our first video lesson of the year, 1.1, solving simple equations. I'm going to try to go through this one as quick as I can because a lot of this you saw last year. But basically, when you look at this, an equation is a statement that has two equal expressions. A solution of an equation is the value that makes the equation true. Inverse operations are two operations that undo each other. Addition undoes subtraction, subtraction undoes addition. Hopefully we are good with multiplication undoes division, division undoes multiplication. You also know that the square and square root are inverse operations as well. So let's just kind of go through a few examples here just to make sure that we are okay with it and we are ready to go. So here's how I want to see these. So first, this is not something you have to do, but think about drawing a line right down through the equal sign. That kind of separates the left side of the equation from the right side of the equation. Anytime I want to go across that line from the left side to the right side or from the right side back to the left side, we have to use those inverse operations. You can't just simply move a number to the other side. Okay, so what I also suggest you do, not so much in these early ones, but circle the variable that you're searching for. Right now it's only a one-step equation, but once we start getting more and more and more operations and things that have to be simplified, knowing what you are trying to isolate to get all by itself, that little circle can be a big help. So then, if I'm trying to get that x by itself, I can see that I have a minus 3 that has to move. So remember, to go across that side, from left side to the right side, I need to use that inverse operation. So minus 3, I would have to add 3 to get the 3 to move. So negative 3 and a positive 3 would cancel out. That leaves me with simply the x. And on the other side, a negative 5 plus 3 is a negative 2. Now, how to check your answer? Hopefully we know if I take my equation, which was x, and I replace it with a negative 2, and then I subtract 3, we are thinking that it should equal negative 5. So we got to prove it. So negative 2 minus 3, that does equal negative 5. So it checks, which means, and you should get in this habit of boxing or circling your final answer to say that x equals negative 2 for this equation. So hopefully that was easy enough. Let's try another one. So looking at the next one. Now we have y plus 2.8. Again, we're trying to get y all by itself. So if I see a plus 2.8, that means to move the 2.8, I need to subtract 2.8 from both sides. Remember, you can't do one thing to one side and not do the same thing to the other side. When I do 2.8 minus 2.8, those cancel out. There's that y that we'd like. And then 0.9 minus 2.8 is negative 1.9. Now, there's nothing wrong with this answer. This is a perfectly fine answer. But one of the things we want to get in the habit of is we would like to have the variable that is isolated on the left-hand side. And so we're just going to simply, no, that's terrible. We're going to move it, just flip it. We're just going to kind of move it from one side to the other. It is an equal sign, so it doesn't really matter. So both of these answers are correct. We would prefer to have the variable on the left-hand side. So if it happens that it lands on the right, at the last second, just kind of flip it back. So it's y equals negative 1.9. Example 2. So using this with multiplication or division. So again, not a difference here. We see that we have our little line going through here. We have the n that we're trying to isolate up on the top. Now it's a negative n over 5. Now remember, n over 5 is like a fraction. Remember, the fraction bar really is division. So if I'm going to move that 5 to the other side, what I'm going to have to do is do the opposite. Now, because it's a negative fraction, I want that negative fraction to become a positive. So we remember that a negative times a negative makes positive. So kind of in one step here, I'm going to kind of make this dividing by negative 5. The opposite would be times negative 5. And I'm going to do that on both sides. If I do that on both sides, I'm now going to have negative 5 times negative n over 5, which does become just n. And on the other side, negative 3 times a negative 5 is 15. And we get the answer of 15. You can check that, plug that right back in. You would get negative 15 over 5. Negative 15 over 5 is negative 3. Negative 3 equals negative 3. So I have the right answer. For letter B, so looks like we get a couple variables here. But if you remember, the pi symbol, that is the symbol of pi, is considered a constant. It is an irrational number that if you haven't talked about in the past, we will talk about that at some point this year. But it is a real national number that keeps going and going and going with no repeating pattern. But it is considered an actual number. So in this one, we're going to treat it like a number. But we're not going to plug in 3.1415 da 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 da. We're just going to leave the pi symbol. So again, we're trying to get x by itself. This says pi times x. So to undo that, we're going to divide by pi. And notice that I'm just going to leave the symbol. Lots of times people will try to turn this into 3.14, multiply it by the negative 2, and then it just becomes very messy and not necessary. See what happens with the symbols. Sometimes they cancel, sometimes they don't, but sometimes they actually do, and we can get some better answers down the road. So when I look at this, pi divided by pi on the left-hand side would cancel out, because pi divided by pi is 1, leaving me with x. On the other side, negative 2 pi divided by pi, again, pi's are both canceling here, leaving me with an answer of a negative 2, which is my final answer. So don't rush to 3.14 or the fraction equivalent, which is 22 over 7. Just leave it as pi. See what kind of things can work out. I'm going to pause the video for a moment. I want you to try letter C, and then come back when you think you have the answer, and we'll just kind of quickly talk through that one. Okay, so hopefully you got the same answer as me. You'll notice that I put the line through the equal sign. I circled my x just to see what was going to be the thing I'm isolating. Because it's 1.3 times x, I'm dividing by 1.3 on both sides to get my answer of x equals 4. So we got to just remember when we're doing our problem solving, some of the different things to think about. So first of all, you want to understand the problem. Really reading through the equation, I think sometimes we don't read through, and think about what are the things that I know, what are the things that I don't know, what is being given to me, and finally, what is being asked. So we need to kind of know a bunch of these things. So read through the problem once or twice. I would make some kind of notes. I might underline a few things. I might circle a few things. And then once I've kind of figured out the stuff that we have, make a plan. It might be a bunch of different problem-solving strategies that we'll talk about in the next page. But figure out what you think you're going to do to get there. There's not always one plan to get there. Some of us might see different problems in a different way, and we can approach them in a different way and still get the same answer. Obviously, going through your steps to figure out your solution. Make sure that as you're going, that each step makes sense, that it's something you can do, and then it's helping you get closer and closer. And always look back. Examine your solution. Make sure it makes sense. There's nothing worse than having a lot of people do lots of work and spending lots of time on a problem and you get to an answer that doesn't really make any sense, but if you don't kind of verify that it makes sense, you're going to have the wrong answer. Okay? So here's an example. So in the 2012 Olympics, Usain Bolt was one of the famous sprinters, and he won the 200-meter dash in 19.32 seconds. We want to solve an equation to find his average speed to the nearest hundredth. So that's something that you might want to just kind of put a little note to, the nearest hundredth, just so that when we're thinking about rounding our final answer. So understand the problem. You know the winning time and the distance. They told us that. You're asked to find the average speed. So that was just kind of understanding what was being given and what to do. Using the distance formula. So hopefully you have seen this before, the distance formula right down here. So the distance formula is the distance, d, equals the rate or your speed. So the rate means how fast are you going, and t would stand for the time. So the rate, how fast you're going, times the time would tell you the distance. So that's the distance formula, and we see the distance formula quite a bit. Okay, so solving the problem. So again, we're going to use that distance formula. So we're going to use d equals r t. So do we have the distance? We do. The distance they gave us was 200 meters. Do we know the rate? We don't know the rate. We don't know how fast he was running per second. What we do know is the time of the race, though, was 19.32 seconds. That's how long he took to finish the race. So once we have this down, now this is just a matter of solving the equation. So on the right side of my equation over here, I can see r times 19.32, which then tells me divide by 19.32. That's going to get me down to r equals, and that's going to become 10.35. Now the question says to the nearest hundredths. So this is our nearest hundredths. Remember, if it was kept going, you would round it to the hundredths place using the thousandths, which would be the third decimal place in. But remember, we also want to make sure that we have a label to any kind of a word problem. Anytime we're doing real life applications, the speed in this case would also be meters per second. So we can't just say r equals 10.35. We want to make sure we attach that label to say meters per second. Now, to look back on that step and says, if I look back, does this make any sense? Well, I can kind of just plug this back in just to kind of verify if it makes any sense. If I can run 10 meters in 1 second, so I'm rounding a little bit, and I'm running for 20 seconds, there's your 200. So it does kind of make some sense. Again, it doesn't make the answer correct. The look back is to make sure that it makes kind of sense in general terms. So here are some of those problem solving strategies that I mentioned on the previous page. Again, a lot of these are going to be just kind of some that you would use on your own. Some will be very definite ones you want to use based on the question. These are just a bunch of different ones that you can kind of think about. So here we go on to our last question, example number 4. The temperature fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27. How many degrees did the temperature fall? So what we want to do is we want to think about, well, what was given to us and what are we trying to figure out? We are given the temperature before and after. We're given that it was at 54 and it went all the way down to negative 4. We're also asked to find the degrees that it fell. Now, in this case, do we care that it was January 22nd? No. 1943? No. Time doesn't really have anything to do with anything either. Sometimes they do, sometimes they don't. But in this case, All we're really being asked to do is find out how many degrees did the temperature fall. Now this is one that I assume most of us can figure out the answer without having to do the next step. But we want to practice just writing the equation. So let's think out. You could have different versions of this equation, but basically what it is this. We're at 54. It fell or went down some number of degrees, and it ended at -4. So if we get to a situation where I say, I want to see the equation before you solve it, you need to be able to learn to build one. So we were at 54, it fell some number, and I know that it fell because it tells us right here that it's falling. And then I need to solve this. Now there's a couple of ways you can solve this, and I'm going to show you one. There is another way that you can definitely do this. So again, we are trying to get x by itself. And this is one that sometimes people make mistakes in. To get x by itself, I have a 54 on the left side also. So remember, the sign that belongs to any number is actually in front of it. So it's a positive 54. And then we're subtracting the x value. So don't fall into the trap of saying, oh, it's subtraction on the left, so I add. Because in reality, you are subtracting 54 from both sides. Okay? This is one that sometimes we see and very quickly try to do too quick, and it throws us off a little bit. But I'm actually subtracting 54. The sign is always in front of the number or the variable. Here's another problem that sometimes we run into. So now, when we subtract that 54, we get the -58 on the other side. We got rid of the 54s, and sometimes we bring down the x. But remember, really, it's not just an x. You also have this minus x. And I can't ignore that. I have to make sure it comes with it. So that -x has to come with it. Now, we aren't trying to solve for -x, we're trying to solve for positive x. So if you think about it, one of the ways to get a -x to turn into a positive x would be to divide by a -1. If I divide by a -1, it'll keep it as an x. Two negatives divided by each other would make it a positive. So there's your x. -58 divided by -1 is 58. Okay, so with that, to solve the problem, it fell 58 degrees Fahrenheit. Again, remember, you always want to make sure you have that label. Now, to look back, talking about the strategies. So think about what kind of strategy might you use to help check this one. Now, certainly you could plug it back in, but I think this is one that you could definitely use that number line strategy. If you were to look at this and say, okay, if I have a number line, it's not a very good number line, should have a straight edge, huh? If I am at 54 degrees and I'm going all the way down to -4, the number line, if I followed it, it would be 54 to this 0 degree temperature, and then a little bit further to get that 58. And that's another way that you possibly could have seen that, or to help you verify that, yeah, that kind of makes sense, that it dropped 54 to get to 0, another 4, which is now 58 to get to the -4. So that's the one-step equations. I don't assume that you'll have a whole lot of problems with those because you should have seen some of that last year. We're going to get moving pretty quickly right into 1.2, which is the multi-steps. But there's a couple of important things I just need you to keep reminding yourselves on the one steps even. Keep yourself neat. Make sure you are showing me the step. Be careful with your integers. Make sure that you are circling your final answers, and we should be good to go into the next section. If you have any kind of questions, please write them down and make sure you check in with me with those questions the next time that I see you, and we will talk soon.